Welcome in today's mathematics lesson, where we are still looking at the algebraic techniques too and indices. And today I want us to look at adding and subtracting algebraic fractions. You all know that when we talk about a fraction, we are simply looking at simply those numbers which are written with the numerator and the denominator. In other words, fractions are numbers like this. Examples of fractions are 2 over 3, 3 over 5, and so on. We have the numerator and the denominator. Numerator and the denominator. So these are the normal fractions. But when you talk about algebraic fractions, here we are looking at those fractions which have pronumerals either as their denominator or their denominator. For example, here we are looking at those fractions like 2x over 5. This is an algebraic fraction because it has a pronumeral as part of its numerator. We can have 2 and 3 plus x. This is also an algebraic fraction because it has got a denominator with a certain pronumeral, and we can also have 2x minus 4y over 7a plus 4b. This is also an algebraic fraction. Now, what exactly will you see here? You find that when dealing with fractions, the approach remains the same the way we were handling fractions earlier in our earlier topics. So you will handle it, you'll add, you'll subtract, or operate on any fraction just the way you have always done it. So let us see how to approach a few things. We all know, given a number like 1 over 3 plus 2 over 3, the denominator is 3, so when you're adding such fraction, definitely, because the denominator is the same, it remains 3, and then we add the numerator, which gives us 3 over 3, which is just 1. So just like the way we operate this ordinary fraction, algebraic fraction also, when they have the same denominator, we shall always add the numerator because the denominator is the same. For example, this is an algebraic fraction, x over 5 plus 2x over 5. What is the denominator? Looking here, the denominator is 5 from the first term and also 5 in the second term. So because the denominator is the same, we shall maintain the denominator and then add the numerator. This numerator, if they are like terms, add them together. If they are not like terms, then we leave them like that. But because here they are like terms, x plus 2x will give us 3x. So we have been able to add the algebraic fractions. In a case where we have different denominators, then this one we shall be required to find the least common denominator and use it to work out. I'll take an example of an ordinary fraction which doesn't have the same denominators, and then we approach it and see how would we have solved that. Look at this. 1 over 4 plus 2 over 3. The denominator is not the same. Therefore, you cannot add. So, which implies that here we shall be required to find the least common divisor, the denominator. And the least common denominator here is simply that number which is the least, and 3 and 4 forms part of the factors. And you'll find that the first one that will actually be a multiple of both the two is 12. And 12 divided by 4 is 3. 3 times 1 is 3, plus 12 divided by 3 is 4. 4 times 2 is 8. And then you'll find that this is 11 over 12. So we have been able to find the least or the lowest common denominator and use it to add this particular fraction. This is on normal fraction. If the fraction is algebraic fraction, if it is algebraic fraction, for example, if we had x over 3 plus 2x over 5. This one is not the same denominator. And because the denominator is not the same, we shall look for the lowest common denominator, the LCD, the lowest common denominator. Now this one, the lowest common denominator here, is simply the least multiple of both 3 and 5, which will give us 15. Take 15 divided by 3, you find it is 5. 5 times x gives us 5x, plus 15 divided by 5 is 3, then 3 times 2x gives us 6x. When you add that, you find you'll have 11x over 15. Always remember, in fraction, simplify where possible and give your answer in the simplest form. This is how we would approach it. So in other words, what should we know, understand, and use when dealing with algebraic fraction? What are we supposed to know? First, we need to understand the algebraic fraction by itself. This is simply a fraction with what? With algebraic expression as the numerator or the denominator. Algebraic fraction is simply a fraction with algebraic expression as its numerator or its denominator. 2, we must know how to find what we call the LCD. LCD stands for the lowest common denominator. Why? Because when we have two algebraic fractions, and here the denominators are not the same, we shall be required to find the lowest common denominator, which is simply the least multiple of the two denominators, which will always form the factors. So the least common denominator must be found when we have different denominators as factors. And finally, we should note that adding and subtracting, this is very important. Adding and subtracting fractions, that is algebraic fractions, requires that the denominator must be the same. Adding and subtracting algebraic fractions requires that the denominator for both the expression, the algebraic fractions, must be the same. We must always remember that. Now, let us look at questions touching on this. How do we work with the denominators? And then how do we add and subtract algebraic expressions? So let us look at that and see how best to approach this. So let us look at this. Find the lowest common denominator. find the lowest common denominator. We want to look at this of the following, of 3x over 10, and we have 2y over 15. Find the lowest common denominator of this 3x over 10 and 2y over 15. Now, the question is, what are the denominators? As we saw earlier on, between 3x and 10, this one here, we call it the numerator. And this 10 here, we call it the denominator. So our question requires us to find the lowest common denominator. So we are concerned about the lowest common denominator. In this particular case, our interest is between 10 and 15. It's between 10 and 15. Now, sometimes there is an easier way of finding it by multiplying, but that is not always the right one. We need to list the following. We first need to list all the multiples of 10 and then the multiples of 15 and see which one is the least. When you have identified which one is the least, that is now what we are going to apply as we work out this. So looking at this, take 10 and we list all the multiples of 10. If you start with this, you'll find that the multiples of 10, those are those numbers which can divide 10 without any remainder. So we want to list all the multiples of 10. They are 10, 20, because 15 cannot divide 10, there will be a remainder of 5. 10, 20, 30, 40, 50, 60, and so on. Then these are multiples of 10. How about multiples of 15? Multiples of 15 are 15 itself, then 30, 45, 60, 75, 90, and so on. These are the multiples. Now, among the two, the multiples of 10 and the multiples of 15, which one is the least and is common? That's why we call it the least common multiple, and that least common multiple will form the least common denominator. So when you start with these 10 and then 20, then you'll find that the first one that is common is 30. That is the least multiple on both factors, and that is the one we are looking for. So these are the multiples that is going to form the lowest common denominator. So, having said that, we can simply conclude and say that the lowest common denominator of 3x over 10 and 2y over 15, then the denominator, the least common denominator or lowest common denominator for 10 and 15 is going to be 30. So we can simply conclude and say that our LCD is what? Is 30. The question reads, convert 2x over 7, which is an algebraic fraction, to an equivalent algebraic fraction with a denominator 21. Now, to approach this, we want to come up with an equivalent algebraic fraction. In normal fraction, we have been having equivalent fractions, but today we want us to look at equivalent algebraic fractions. That means if we have 2x over 7. We want to find what could be the other alternative algebraic fraction which will form 21 as its denominator. What will be the equivalent numerator? It is very simple. You only need to take what you have as your final denominator, which is 21. You divide by the first denominator, which is 7. Then that one will tell us how much of this was multiplied with the denominator to give us the 21. So 21 divided by 7 is 3, which means that also above we must multiply by 3. So you'll find that 2x over 7 times 3 should give us 21. Now, you see, this is what I'm saying. 7 times 3 is what? 21. How about 6x times 3? It will give us the equivalent algebraic fraction, which will be what? 6. This one is going to give us 6x. So, by that, it means that 6x over 21 is an equivalent algebraic fraction of 2x over 7. Now let us come to adding and subtracting algebraic fractions. We want to add and subtract algebraic fraction. Now look here, we are going to have some questions and then we look at it and relate the knowledge of fractions and see if we are going to be able to add and subtract. Simplify the following expressions. So I want us to handle each independently one by one. We'll go through one question, we simplify it, and then move to the next. Now, we've been given, simplify the following. 3x over 11 plus 2x over 11, 3x over 11 plus 5x over 11. 3x over 11 plus 5x over 11. The first thing we ask ourselves, before we add and subtract any algebraic fraction, we must ask ourselves, is the denominator the same? Is it or is not? Definitely the answer is clear. Our denominator here is 11 for the first term and 11 for the second term. So we can agree that the denominator is the same. So we shall say this one is equals to the denominator, which is what? 11. And then now look at the numerators and then ask again, do they represent like terms? Do they carry the pronumerals which are the same? If they have powers, the powers are the same. If they are like, we go ahead and add. 3x and 5x both have x as its pronumeral, which means they are like terms. So this one will be 3x plus 5x. So when you add this, it will give us 8x over 11. 8x over 11. So this is our answer. And remember, we've said simply because these are like terms. Again, simplify. As we go on, we keep on advancing and introducing a new principle. Simplify the following expression, 4a over 3 plus 2a over 5. 4a over 3 plus 2a over 5. As I said earlier on, we are adding, and if we are adding, check the denominator. Ask yourself, are they the same? If they are the same, proceed. Look at the numerator. Are they like terms? If they are like terms, you add, and there you go. For this particular case, are the denominators the same? 3 and 5. Definitely the answer is no. And if the answer is no, we move to the next step that tells us that we must find the lowest common denominator for 3 and 5. You should be able to get that. So we are saying because the denominators are not the same, we find lowest common denominator. So let us list these. Let us list the multiples of 3. It is 3, 6, 9, 12, 15, 18, 21, and so on. Multiples of 5 is 5, 10, 15, 20, 25, and so on. From here, which one forms the least multiple? 3 is not here, 6 is not here, 9 is not here, 12 is not here, 15, yep, we have 15 there. So our lowest common denominator is 15. So we can go back and proceed with our answer, having known our least or our lowest common denominator as 15. So we have our least common denominator as 15. Then we take 15 divided by 3 is 5. 5 times 4a, right? Then plus, this is just on the same denominator. 15 divided by 5 is 3, then 3 times 2a, 3 times 2a. So this case here, we find that, well, we have 15. We find that we are able to now to finish the order of operation by dealing with the multiplication from the left. So 5 times 4a gives us 20, 20a, and then plus 3 times 2 gives us 6a, all of it over 15. The numerator are showing us that they are like terms, which means they can now be simplified and put together. So we go ahead and add them, and you'll find 20a plus 6a gives us 26a, and the denominator is 15. If there is a place to simplify, please do simplify. But for this particular case, we don't have any common factor between the two. So this is our simplest algebraic fraction. So our answer becomes 26a over 15. That is our answer. So we have seen addition of algebraic fractions with the same denominators, addition of algebraic fraction with the different denominators. Now let us look at subtraction. Simplify this. 6k over 5 minus 3k over 10. Now, by now you should be able to know how to find the least common denominator without going all the long way of listing all the multiples. You should be able to just get it so easily and see. Looking at the two, you'll find that one of the denominators forms a multiple of the other. If that is the case, then that one that forms a multiple is our least common denominator. You realize that 10 forms what? A multiple of 5. Therefore, 10 is our least common denominator. 10 divided by 5 is 2. Then 2 multiplied by 6k minus 10 divided by 10 is 1. Then 1 times 3k is 3k. So moving ahead, 2 times 6k gives us 12k minus 3k over 10 over 10. Collecting like terms, these are like terms. So 12k minus 3k gives us 9k over 10. 9k over 10. So this is our simplest answer when you subtract 6k over 5 minus 3k over 10. This is what you get. Lastly, let us try this, and this one is more simpler. A over 6 minus b over 9. A over 6 minus b over 9. This one, if you choose to find out what happens here, we can do it mentally to find the lowest common denominator of 6 and 9. For the above, we have got unlike terms. And this is now what I'm saying. Every time we move, we introduce new working methodologies. So A and B are not like terms. I don't expect you to simplify A and B by adding them together or subtracting them, because they don't work. So what am I trying to say here? Then it means that we are interested first in finding the lowest common denominator, and then above it, the numerator will remain independent. We cannot simplify them further because they are not like terms. So mentally, we can work out the lowest common denominator for 6 and 9. You'll find it is 18. 18 divided by 6 is 3. 3 times A is, so we have 3 times A here, and then minus 18 divided by 9 is 2, then 2 times B. So that's what we have. This one you'll find that it will give us 3A minus 2B, the whole of it over 18. Now, look at it closely and see, is there any further step we can make? You realize that there is no any further step we can make because 3A and 2B are both unlike terms. The denominator remains. So we conclude and say, this is our answer. This is our algebraic fraction, where we have an expression forming our numerator and the denominator as 18. So sometimes we normally have something that is necessary. We need to know how to come about it. When you have various fractions together and then you get the LCM, that is or we call it the LCM, that is the least common multiple or the lowest common denominator. It just means the same thing, lowest common multiple, lowest common denominator or least common multiple. It all means the same thing. Now I'm saying, if you have a series of fractions, and this series of fractions, we are either adding them together or subtracting them, then they are supposed to form what we call equivalent sums or equivalent differences. So let us find the following from that. I'm talking of equivalent sums and equivalent differences. Now this one is simply a combination where you are asked to write a series of fractions as simply one algebraic fraction. Look at this. Now we have a sum of 3 different algebraic fractions. That's why you are talking about equivalent sums. 1, 2, 3. There are 3 algebraic fractions, and we want to come up with one single algebraic fraction. Looking at this, it is z over 4 plus z over 3 plus z over 12. Using common sense, you'll notice that we need to find the lowest common denominator for 4, 3, and 12. And mentally, we can work out and find that one of the denominators is simply a multiple of the others. That is, 12 is a multiple of 4 and 3. Therefore, 12 forms the lowest common denominator. So we shall have 12 coming here. 12 divided by 4 is 3. 3 times z gives us 3z plus 12 divided by 3 is 4. 4 times z gives us 4z. And 12 divided by 12 is 1. 1 times z is simply z. What we have on the numerator are like terms, so bring them together. 3z plus 4z plus z will give us 8z over 12. That is 3z plus 4z is 7. then plus 1z gives us 8z over 12. Now here, this is not our simplest algebraic fraction, but we are allowed to simplify it further by looking at the common factors that can simplify 8 and 12. You realize this is 4 by 4 here is 2 by 4 is 3. So the answer becomes 2z over 3. This one is our equivalent algebraic fraction of the sum of these three algebraic fractions. We should be able to add or maybe to subtract a chain of fractions put together. Maybe let us handle another question where we have a subtraction and maybe bring in a whole number and we see how to approach it. So for each of the following, remember we want only to find a single equivalent algebraic. Find single algebraic fraction for 5x over 12 minus x over 3 plus 2. This is very, very interesting. We have brought in a whole number, which requires us to remember what happens when we have fraction and whole numbers or whole numerals being added or subtracted together. So we saw it in our previous classes that if we have a whole number and a fraction, then we shall introduce a denominator of 1 for the whole number so that we are able to make it as a fraction and we move ahead. So for us to work out this, we shall be forced to introduce the denominator of 1. Remember, I've not changed anything because 2 divided by 1 is simply 2. Now, having reached there, we move ahead now and find the lowest common denominator. And our lowest common denominator here is 12, because 12 is a multiple of 3 and 1. 12 divided by 12 is 1. 1 times 5x is 5x. Minus 12 divided by 3 is 4. 4 times x is 4x. And then 12 divided by 1 is 12. 12 times 2 is 24. So plus 24. Like terms, bring them together, and like terms, we leave them aside. So 5x minus 4x is x, and then plus 24 divided by 12. Look at that. We have been able to reduce all this into a single algebraic fraction. This is a single algebraic fraction. That is how we work out that. Having said that, now let us move further now and look at multiplying and dividing this algebraic fraction. We have seen how to add, we have seen how to subtract them. Now we want to advance and see how do we multiply and divide algebraic fractions. Now, multiplying and dividing algebraic fractions. You'll notice this. It is even much more easier to deal with multiplication and division of algebraic fraction than even addition and subtraction of the similar fractions. Why I'm saying this is simply when you're multiplying fractions, the numerators are multiplied together, the denominators are multiplied together. What the numerator forms remains there, what the denominator forms remains there, and then you simplify where possible. When you are dividing, as we shall see here, we same as multiplying by its reciprocal. And when we talk about a reciprocal, you will realize here that it is simply when we reverse the numerator and the denominator. What am I saying here? Look at this. For example, 3 over 5 multiplied by 2 over 7. You see? This is straightforward. You don't need to struggle. You just work out straight. The numerators, multiply the numerators alone. 3 times 2 is 6. And 5 times 7 is 35. That is it. As simple as that. Multiply the numerators, multiply the denominators. Supposing it was algebraic fractions being multiplied, how would we have done it? The same way, 4x over 7 now, the advantage here, the like terms and like terms will not disturb us. Ours is to multiply. 4x over 7 multiplied by 2y over 11. Again, the same. Take the numerators. They multiply together. 4x times 2y. This is the same as 4 times x times 2 times y. See? And down here we have 7 times 11. 4 times 2 is 8. X times y is xy. So we have the numerator forming 8xy, and the denominator is what? 77. So it's 8xy over 77. It is easier to multiply fractions. And the same way it is easier to multiply fraction, we find it also easier to multiply algebraic fractions. So let us move to division, and again you see how interesting it is. In normal fractions, if you are given a number like 4 over 5 divided by 1 over 3. If you are dealing with ordinary fractions, which are not algebraic fractions, this is the same as taking 4 over 5 multiplied by the reciprocal of a third. And the reciprocal simply means invert or change the numerator and the denominator of the fraction you are dividing with. That means we shall multiply by 3 over 1. It's no longer 1 over 3, but the reciprocal of 1 over 3 is 3 over 1. And now here you are, it's just a fraction. You multiply 4 times 3 is 12, and 5 times 1 is 5. So you find your answer as 12 over 5. Or if you prefer writing as a mixed numeral, this will give us 2 and 2 and 2 over 5. It's still allowed. For algebraic fractions, we have this 2x over 5 divided by 3y over 7. As we have just seen that when dividing is the same as multiplying by, it's what? It's reciprocal. So we shall write this and have 2x over 5 multiplied by the reciprocal. What is the reciprocal of 3y over 7? Ask your colleague, what is the reciprocal of 3y over 7? Yes. So you realize that you have been told that we invert this, which will give us 7 over 3y. That is the reciprocal. Anywhere we can simplify or cancel, we do. But for this case, it seems to be straightforward. 7, that is 2x times 7 over 5 times 3y. 2x times 7 over 5 times 3y. This gives us 14x over 15y. It gives us 14x over 15y. And that is our answer when you are dealing with this. That is our final answer. So let us note the following. To multiply algebraic fractions, then to multiply algebraic fractions, 1, multiply the numerators first, and then multiply the denominators. The two of them are multiplied separately. The numerators are multiplied separately, and they'll form part of the numerator of the equivalent fraction we are looking for, and the denominators are multiplied again separately to form the part of the denominator of the new equivalent fraction we are looking for. Just to illustrate this, so here we have algebraic fractions, and we want to multiply the numerators together, and then we also multiply the denominators, because that is the rule. And when you do that, finally, cancel any denominator with the common, cancel any denominator and the numerator which shares or has common factor. So if it will happen like that, then we shall cancel. Let's see. 2x times 10y will form 20xy. And 5 times 3 gives us 15. Take note that 20 and 15 have got a common factor of 5. So by 5 here is 3, and by 5 here is 4. So this one gives us 4xy over 3. 4xy over 3. This is our answer. 4xy over 3. So that is the first rule we shall need to observe. The second rule is about this reciprocal issue. Reciprocal here is simply what we are saying: you invert or you change the denominator and the numerator. You change the denominator and the numerator. Now, when is it applied? When dividing algebraic fractions. The second fraction, we shall change it. We shall get the reciprocal of the second fraction. So it will be taking the first fraction and multiplying by the reciprocal of the second fraction. Remember, reciprocal of an algebraic fraction is formed by swapping the numerator and the denominator. Is formed, this is the reciprocal of algebraic fraction, is formed by swapping the numerator and the denominator. How is that done? We realize that we have 2a over 5 divided by 3b over 4. 2a over 5 divided by 3b over 4. Look at the rule. We are dividing algebraic fractions, so reciprocal of algebraic fraction is formed by swapping the numerator and the denominator. So the first fraction remains. I'll maintain that. Then multiply by the reciprocals. If you swap this, it will be 4 over 3b. That is what I wanted to show. So we are saying that 4 over 3b is simply the reciprocal of 3b over 4. So you can move ahead and conclude here and say 2a times 4, which gives us 8a over 5 times 3b, which gives us 15b. This one will form our answer. So let us look at a few examples on this, and we must be able to illustrate and explain them correctly the way it is required. Let us look at a few examples, and here we should be able to actually apply the points we have gone through when multiplying and dividing algebraic fractions. Simplify the following products. Yeah, look at this. We are only to multiply and simplify. From what we have seen, there is no division, so we shall move ahead multiplying the numerators alone separately, and then denominators also separately. So this one, the numerator here, we shall have numerators multiplied together, that is 2a times 3b over denominator is 5 times 7. This one will give us 2a times 3b is 6ab over 35. 6ab over 35. This is our answer. That is our answer. And for the second question here, we shall take the numerators again. That is, numerator is 4x times 3y, and the denominator is 15 times 2. This one gives us 4 times 3 is 12, and then xy. (15 times 2 is 30). Now, when you reach here, what is common? What is a common factor between 12 and 30? You realize that 6 is common for both. So we divide here by 6 is 2, by 6 is 5. So when you reduce this, you'll find it remains 2xy over 5. We have 2xy over 5. That's what we get for that particular part. Looking at the part that touches on the division, now, again, with this time we need now to apply the issue of a reciprocal. So simplify the following divisions. This is divisions. Simplify the following divisions. And the ones we have is a. So we have these questions. We are to simply simplify the divisions, that is 3a over 8 divided by b over 5, and u over 4 divided by 15p over 2. So for the first part, dividing algebraic fraction is the same as multiplying by its reciprocal, so this one will be 3a over 8 times the reciprocal of b over 5 is 5 over b. Then we move ahead and multiply the way we do it in fractions, the numerators together and the denominators together. So 3a times 5 gives us 15a over 8 times b gives us 8b. Looking at the two, there is no any common factor that exists, so it will be our answer, 15a over b. For the second part, we have u over 4 divided by 15p over 2. So this one will be u over 4 multiplied by the reciprocal here, and the reciprocal is 2 over 15p. If that is the forms the reciprocal, then we can go ahead and multiply. We have u times 2 over 4 times 15p. This one, you realize it will give us 2u over 60p. 2 and 60 has got common factors. You can simplify by 2, 1 by 2, 30. Then we find our answer is u over 30. u over 30. So this is how we handle algebraic fractions, when adding, subtracting, multiplying, and dividing. I believe when you meet any similar problem, you'll be able to handle it without any problem. And in our next class, we shall be expanding the brackets. That is it for now. Thank you.